That's good. So hopefully my hope is that sort of the scope for today, I'm calling it advanced data prep, but I hope that even if you've never worked with JUMP much or never worked with data preparation much, you get value out of it. I also hope that those of you who have done extensive data preparation see some ways in JUMP that maybe we do it a little differently. If you're new to JUMP but you've used other tools, you may have noticed that there's hundreds of different ways to do things in JUMP. And one may be more advantageous in a particular circumstance. My hope is that it can give you a little context around why one might choose a particular path or a particular tool. So if you are advanced and I'm showing basic things, I hope you pay attention to those little nuances where I say this may be more advantageous in this circumstance or not. But I hope everyone comes away with some real value. Now, sort of speaking about today, let me just give you a sense of what I want to talk about, and then we'll get right into JUMP really quickly. I don't like a lot of preamble for it. My thinking is I'll start just with some high-level discussion of types of data preparation methods. I like to distinguish what the methods are doing just to give us context around the tools themselves. I think it helps to group them. I'm going to start with 10 plus examples. I think in the description I said 10 tools. I started writing the talk 6 months ago and I got past 10 really quickly, so it's 10 plus. So it's really going to be 10 classes of data preparation tools. And it's going to be a lot of them, actually, because I want you to see the scope, because so much of data preparation is having the imagination how to get from your messy data to your finished data and seeing how you're going to string together multiple tools. It's really, please, join. It's really uncommon that any single process or any single tool will really prepare you completely. And so we're going to see a lot of them sort of so you can see the constellation of tools that you can then string together. And then what I want to do at the end, before we open up certainly for time for questions and back and forth discussion, I want to work through a few case studies where we have to do exactly that, string together multiple tools so that we can get from our messy data set into something that we can actually analyze. So that's my thought process for today. I realize it's a fairly pithy outline, but I kind of like to keep things open. Please interrupt me. I have a tendency to just keep talking if no one stops me. So if there's ever things you want to see more elaboration on, or if you have questions about why I did something, or if you just need more time to look at the consequence of something I did, just please interrupt me. Okay, so this type of data preparation method idea, I'm going to distinguish sort of 3 classes of data preparation. Actually, I'll pause already and say something. I am recording this. I'll make the recording available just to you all since you signed up for this tutorial. But don't feel like you have to write anything down because you'll have the slides. These will all be available, but only you will get the recording. So if you want to go back, you can. So types of data preparation. I like to think of these in 3 big classes. And some of this comes from my background in graphic design. I sort of stole these terms. And so the first kind of method type I'll talk about is constructive methods in data preparation. And just to give you a sense of what these might look like, constructive in the sense that you're building on top of data and adding something to it. So this could be creating variables, deriving variables from other variables. We'll see this today with formulas. Things like recoding a variable, taking a variable and the categories within that variable and transmuting them into a new variable, taking categories, combining them, splitting them apart, things like that. Setting column properties. Metadata within a data set is data itself. So when you add properties to columns, whether it be value ordering, whether it be value labels, whether it be coloring, all that is adding data in a sense. You're adding stuff that allows you to see new things. Joining, merging, concatenating. In a sense, that's constructive. You're taking data that exist in different sources and putting them together and establishing relations between things. Right? You don't just take data and squish it together. You align them based on sort of rows that match or characteristics of the data. So you are adding value, adding information. And imputation, I have a little star there because we can have a big argument about whether imputation actually adds information. From an information theory standpoint, it really doesn't. But from a modeling standpoint, you may regain the ability to use certain rows if you impute. And imputation, if you don't know that word, it's missing data. You are adding values back in based on some structure that you're presuming about the data set. So oftentimes this is assuming linear relationships between variables and adding in values where you expect them to be if they're missing. So we can argue about that being constructive or not, but we'll leave that for now. Okay, so contrasting with that, there are destructive methods to data preparation, and some of these are necessary for the process of analysis. So we can think of things like summarizing, taking variables and calculating means on them, maybe means broken apart by certain categories. Sometimes you just need to report a table of means. That's a destructive method in the sense that once you have just that table of means, you can't reconstruct the original data. And I stole this from photo editing. If you are applying filters to a layer, or if you're making changes to brightness, contrast, and doing it in certain ways, you can't go backwards. You have destroyed, in a sense, the original data and end up with something new. Tabulating, in the same way that summarizing is destructive, you end up with something that you can't go back from, right, if you don't store the original data. Of course, deleting records, something you shouldn't do in JUMP, we can always exclude. Recoding in place, again, something you probably shouldn't do. Taking a variable and writing over the original variable, that's very hard to go backwards and not recommended. And then there's a tool in JUMP I specifically called out here, update. This is a type of importing or merging method where you have a data set and you want to replace values in your original table. So maybe you get new sales and you want to write over the existing sales in a data table. And so you can't really go backwards from that. Now, I mean destructive, of course, assuming you haven't saved backups. There's good workflow where you save backups of your data set, create versions, and all that version control is sort of outside the scope of today. But from a standpoint of sort of thinking about these tools, these are what I would call destructive. And then finally, not destructive or constructive, but non-destructive. So data prep methods that just change the way your data is oriented. And so we'll talk about some of these today, like stacking and splitting. These are reorienting the way that observations are stored in your data set, changing units of analysis maybe across columns to across rows or rows to across columns. So we'll look at those. Transposing, literally flipping the rows and columns of a data table. You're not destroying any data, you are reorienting it, and that has certain affordances within JUMP and all statistical software. Software expects data to be stored in a certain way such that it can operate on it. Excluding and hiding rows, non-destructive. You're simply telling JUMP which things to use and not use. And then taking subsets and views of the data. And data view is a real nice thing in JUMP we'll talk about. So those are non-destructive. So just as a superclass of thinking about tools when I talk about them today, I like these categories because they change what sort of things you should think about when you're doing them. Okay, so that's actually all the PowerPoint. I don't like PowerPoint very much. So we're going to pop right into JUMP. And I'll certainly share this journal with you today. It'll be on the community page for the whole Discovery Conference. All the data sets that I reference in here, they'll actually be inside, so you'll be able to play with them yourself too. Just a point of question, is the font size okay? Everyone can see decently okay? And I'll, when necessary, zoom in for you. I'll try not to do it too fast. It makes people sick. Okay, so to start, let me just sort of talk about these classes of tools. Again, there's going to be more than 10, but there are 10 big classes. We'll talk about table formatting and import type tools. Data restructuring, those are the tools that I talked about being non-destructive, like stacking and splitting. We'll talk about data aggregating tools, tabulating and summarizing. Data merging, join, update, concatenate, and query builder, a way to perform these operations all at once using JUMP's implementation of SQLite. Table views, things like subsetting, the data view function in JUMP, which is really powerful, and using the row editor, which is also really powerful. Things we do with missing values. I won't talk about imputation per se, but I will talk about ways to visualize what data you have that are missing and how you might identify which rows are problematic. So we'll use missing data pattern and explore missing values. Missing variables, so getting into constructive methods, we'll talk about the formula methods in JUMP, instant formulas, temporary formulas, column formulas. A couple specific things, making indicator columns and binning. We'll see about extreme values. So this is sort of a separate idea in data preparation, values you don't trust in your data set and how you might identify them. We'll talk about univariate, multivariate, and model-based methods for this. So different approaches to how we think about outlining this and some of the ways we can work with them. Straight wrong values, so recoding, and don't overlook it, find and replace can sometimes be really, really powerful in JUMP, especially since it supports regular expressions. And then finally, some basic interface and data set tools like data filters, the unbelievably powerful select matching cells, something you can use a lot of times, row state columns, and then text to columns. So we'll talk about all these, I assume, in an hour and a half. Okay, so going right into it. So table forwarding and import. So I'm going to pull up in a table here. This is a table we can already see. It has information about cars. And so we have Volkswagen, Acura. We can sell based on the values in the column that's what we have. We have information here. But we have no column names. And I should say my background, I did a lot of research psychology. I'm an experimental psychologist. And so often people would send me tables from surveys they did where they just had no column names. And it's an unbelievable strange way to store data because we haven't identified what our variables are. And they would often send me a different file that has the sort of data dictionary, what the column names should be. And this was always just a frustration to me, especially when I was working only in JUMP or in R, and I needed to align these with the table. And so if you haven't noticed, JUMP has, of course, this column section on the left, and these sections are all actually independent pieces of the JUMP table. And there are affordances of this, most notably that you can actually paste into your columns list a column names list. So if you have these column names and somebody has sent that to you, with them selected here, I'll just select, you can just paste them right in and add in all your column names. And this ends up being an incredibly powerful prep tool because you can now just take those data dictionary column names and put them in. You can also copy them back out. So if you copy from there and you need to make edits, you can actually do that in other software and go back and copy them back in. So again, if you want to see that again, I'll just undo. With them selected in the columns list, and you'll see when I select, I can tell that this section is selected based on the indicator at the top. And so with that selected, you are now highlighting not the data, but the columns themselves. I'll just copy out the column blank names here. And so you can see I can paste them back in. So I can go either direction, and it becomes incredibly powerful. So something to know, and something certainly to use. Let me just hide PowerPoint so I don't keep doing that. There we go. All right, so pasting in column names ends up being incredibly useful. I'll do that one last time for you here. All right, so within data import, there's of course plenty of other things we could talk about. I'm just going to keep going because I want to get to some other tools, of course. But be aware that there are lots of things JUMP does to make importing easy. Of course, you've seen the data preview when you import from a text file, and hopefully you've also seen that there's a multiple file import. I'm not going to cover that today, but if you do have multiple files that are of the same type, you can actually let JUMP pull them all in and stack them together for you. So you can do really powerful things with that. So we can come back to that if that's of interest to anyone later, but I want to keep going. So data restructuring. So this is a big class of non-destructive method. It ends up being one that will enable you to do a lot of things in JUMP that you couldn't do previously if your data come in a certain way. And so I want to talk about stack splitting and sort of talk about some options with them and ways you might not know to use them. Just to give you an example, so I built this really simple base table, and I've labeled things in a particular way because I want you to notice where observations go. But just so you can see, I have 4 rows. I actually have a column called row, because once we change where the table is oriented, I want you to see where values go. We have columns A, B, and C, and then I've labeled each of the values within each column based on the numerical position in the data set, so 1, 2, 3, 4 for each. So what if we needed to, in some analysis, have a variable that identified these A, B, and C columns? For instance, what if A, B, and C were different attributes of the same thing? And we wanted to have, in some analysis, a variable that we can say attribute with. So stacking is an operation that will take data like this, which are we would call wide data, data where these variables represent some units, and there are cross variables. We want to take that into a table that's called tall. So where we have a longer table, but we have a variable that identifies the A, B, and C's. And let me show you what it looks like, and hopefully that'll be more clear if you've never seen a stack. So if I go to tables stack, and I'm not going to change anything yet, but I'm going to do keep dialog open because I want you to see what happens when I do the simplest of stacks. I'll take A, B, and C, put them into stack columns, and click create. And if we look at the 2 tables and look at how the observations were moved, row 1 here, right, with A1, B1, and C1, now is represented across 3 rows. A, B, and C, the previous column variable headers, are now labeled. They're part of a variable called label. And the data, A1, B1, C1, is now in a tall format across the rows in a column labeled data. Now, label and data are what were specified here. So if these were actually something different, let's imagine if I go back, let me just delete this table. Let's do it all over again. I'll go to table stack. What if we knew that these particular values, A1, B1, and C1, they were, I don't know, some specific type of outcome? Maybe they're parts per million of some measurement we have, but they're of different, maybe, chemicals. So we have ppm is the data, and chemical is the label. That's what A, B, and C actually stand for. If I create this stack, I'll keep dialog open again, Jump will actually label the columns for me appropriately. So notice that the stack data column and stack label column, those just define the names of the data set that comes after. But really, the only thing you need to specify is which columns you want to now rotate and put across rows. Now this becomes very powerful because, again, if you need to use that variable within an analysis, for instance, in fit y by x, you needed a variable that defined what chemical was, and parts per million needed to be the response. Of course, it would be numeric in the actual example, right? That wouldn't be something the data table would afford you in the original format. If I have this original table and I want to analyze how parts per million varied across, there's no way I can define that. I don't have a variable like I do on the right-hand side that let me define the different chemicals. And so when you start thinking about how your data is oriented, you may ask yourself, do I need a variable that defines this thing? Now let me go to an actual example of this simple kind of stack that gives us some real variables before we do a multiple series, a different kind of stack. And I'm just going to pull up in the sample file. I guess I linked it wrong here. It's called dogs, and it's one of the ones in the sample data library. If you don't know where that is, it's under the help menu, and I just went to sample data, and I'll pull up in dogs here. And this is measurements of histamine levels for these dogs that are on different drugs. And so what you have is histamine at different time periods. So this measurement is numeric. We have these different dogs there. You can see the ID numbers increment. So dog 1 is all across this row. And if we wanted to ask ourselves a question of did histamine change across time, we could probably, with Graph Builder, although it's a little bit harder, craft a graph where we have histamine 0, 1, 3, and 5 for each dogs and draw a line between them. It's possible because Graph Builder is very flexible, but it'd be a lot easier if we just had a variable that said time period, 0, 1, 3, or 5, and then we had histamine level as just one outcome variable. So let's try this one. I'll go to table stack. I'm going to take histamine 0, 1, 3, and 5. And we know the data here is actually histamine level, and the label, what these levels define, is time period. Let me keep the dialog open here. Now, I'm going to click Create, but I want you to see it gets complicated because I have all these other variables in the table that are just replicated, right? Because dog 1 had a bunch of other values, right, that actually we're not using for this analysis. And what Jump has to do is put them across rows as well. Because if we're going to represent 0, 1, 3, and 5 for dog 1, all those other variables have data, and Jump doesn't just want to eliminate it unless you tell it to. But for simplicity, let's actually do that. I'm going to show you another option within this window, within Stack. I'm going to say select or keep only certain columns in the new table. I just want to keep drug and ID. And of course, Jump will keep the histamine columns because I'm stacking those. But I want to make a simpler table, so I'm going to tell Jump to just keep some of those. I can also do the inverse, drop the ones I select, but I'm going to say just keep these. And so you'll see this makes a lot simpler of a table. Drug 1 is right, or dog 1 is right here. There's the 0, 1, 3, and 5 time period, and there's the histamine level. Now, just so you can see what I mean about the affordances of this structure, if I go to Graph Builder, I can say, well, show me the histamine level on the basis of time. And for ID, let's make that nominal, and I'll put that as an overlay and do some lines. And so now I have, for each dog across each time, the histamine levels, and I can actually visualize them. If I was working with the original table, that becomes a lot trickier. I mean, there's ways to do it, but notice that instead of having a variable I can put on the x-axis, I have to sort of convince Jump to use all 4 of these, draw across them, and ID by time, and you have to do some stuff with combining the scales and make them parallel and some other things. We won't do it. It's a lot more work. If you have a variable that identifies time period, it's as simple as putting that as the x. So affordances of a stacked structure. Now, if we're in this stack structure, let me just minimize this one. Going backwards, remember, if we didn't eliminate rows, this would be non-destructive. If we didn't eliminate columns, this would be non-destructive. But just for simplicity, I'll stick with the simple one where we did eliminate those columns. Moving backwards, I can reconstruct that wide format table pretty simply. It's just under tables split. Split is the inverse of the stack operation. And the way it works is you have a split by column and a split columns, which sound very similar, but once you've used it enough, you'll see why they're labeled exactly that. The split columns are the data you want to now be represented in the new table. So what column actually contains the histamine levels you want to reorient. So that's hist level. And split by says what is the variable that will identify the new column labels? What variable is it that was the column headers before? And in this case, it's time. Now group is if you have something that identifies the individual units and you want to enforce that that is stored in the new table and also aligns the responses. In this case, we have ID. ID identifies the units because you see dog 1 here is what is represented across those 4 rows. Almost always JMP will figure it out on its own if you have tables that are well formed. I like to always specify that if you have it. So saying what identifies those units. And you will again have the option of whether you keep all the other columns or data or drop them all. I usually select keep all, and I usually select keep dialog open just so I could always go back and make changes if I need to. So let me hit create, and you'll see that we get back to the original table. It's now just reoriented it. And that missing value was always missing, by the way. It didn't just lose a data point out of nowhere. So notice you can go back and forth. All day you can have fun and stack your split table again, and then you can split your stack table again. So there's no need to do this. No one has fun like that, but you could. Okay, any questions on what I would call the simple stack and split operation here before we look at a slightly different version of it? Good. Well, let's look at a multiple series. So sticking with this base table idea first, I want you to just take a second to soak in what this looks like. So again, imagining we can say chemicals, and these are parts per million we're measuring. And so we have chemical A, B, and C. What if we had, instead of just chemical A, B, and C, we had 2 slight variants of chemical A, B, and C? So they were really the same chemical, A1 and A2, but just manipulated some very tiny way. So we would say that A1 and A2 are really the same thing, just slight variants. B1 and B2 are same thing but slight variants, and C1 and C2 are the same thing with slight variants. We could stack this whole table, and I'll just do this quickly. So if we stack, take all the columns, I won't do any of the labels. We could stack because really it is true that these are different columns. But what if we wanted something slightly different? We actually wanted the series 1, A1, B1, and C1, to be all in one column with the data. And we wanted the series 2, A2, B2, and C2, to also be in an aligned column, such that we end up with A1-1 and A2-1 on the same line. So if you can imagine that, that would actually be nice because sometimes we want to treat those in a multivariate way. They're the same instance or the same unit across that other type of variable. So let's see how we would do this. So the simple stack gives us this tall table with 24 rows because we've just moved all the data from columns to rows. But if we want to treat them as multiple series, this is an actual option under your stack platform. So there's this multiple series stack option. And let's take a second to look at this. So before I change anything, I'm just going to take our columns. There are 6 of them. I'll put them into our stack column section. And the way JMP asks you to define this multiple series is by asking you how many series you have, and it can figure out which orientation the columns are in. So if I'm considering my series to be this block of 1, this is, a series. We can say like this is all together a series, and this is a series. So we'd have 2. Or we can say that we have 3 series. We have, A1, A2, B1, B2, C1, C2. So depending on which orientation we're thinking about it, those are either 2 series or 3 series. And in this situation where we have 2 series, notice that all the series 1 are contiguous. They're next to each other. And all the 2s are contiguous. And in the other orientation, they're staggered. So they that's one series, this is one series, this is one series. Let me make this a little more concrete. In the definition here, I can actually specify how many series I have and whether the columns are contiguous. So we'll say, let's try that first option where we have two series, the ones and the twos, and they're contiguous. They're next to each other. And let's see what kind of table that gives us. So there it is. And I'm going to go back really quickly and just do the same thing, but do the other one. I'll recall, and I'll say that we have three series that are not contiguous. That's, again, treating the A1 and 2 as the same thing, B1 and 2 as the same thing, C1 and 2 as the same thing. And I'll hit OK. So these are perfectly legitimate stacks, but treating the data a little bit differently. And let's look at what happened at the top when we said we had two series. So now we have three rows representing that first row in the table. And A1 and A2 are on the same row, right? So we've treated A1 and A2 as a series, so they actually get stacked. And so we have A1-1 and A2-1. Compare that to the situation where we said we had three series, which is really that all the A1, B1, and C1s are the same thing, and A2, B2, C2s are the same thing. So that's down here. We have A1, A1-1, B1, B1-1, and C1, C1-1. And then we have the twos as a separate row. So depending on what you're after, these are both perfectly fine stacks. It just gives you data in a different orientation. And so the multiple series stack, this is one that, I'll be totally honest, when you first start using, you end up kind of playing around with a few times. You'll end up keeping that dialog box open. I highly recommend you always check that button, because you frankly will end up stacking multiple times to see what's going to give you the data you need. But the big thing to remember is whether you're talking about contiguous columns or talking about non-contiguous. And again, the contiguous would mean that your series have all the data in the columns aligned next to each other. And then the next series starts as a group of columns. Now, I should say it doesn't really reflect the table itself, just how you enter them into this stack column section. So if I had entered them in here differently, I mean, it's nice to take them as a block and put them in, but you can also enter them individually. So this contiguous, not contiguous, doesn't really depend on the table so much as how you define them. All right, so that one's a little bit more complicated. Any questions about the setup of that at least, or what we ended up with? Okay, let me show you a real-world example of that maybe works a little better once you see it than just having these abstract columns. And I'm going to pull up this teaching survey. This one had the situation where they entered their column names is ridiculous. So let's actually just, here's another nice thing. You can take the first row of a table. Oftentimes that has, from Qualtrics especially, the actual fields, right? And instead of having these ridiculous column names, I'll just copy the first row. I'll select all the column names and paste. So now it fixes that. They're duplicate columns because they were identified the same, so I can just delete that now. All right. Without getting into it, this is a variant of a teaching survey, and we asked people a bunch of questions about what kind of classes they taught. And in here, you have essentially 5 courses that people could be asked about. And we asked them, what they're teaching this semester, how many students they have, what level the course is in. And so basically for each of the 5 classes that they entered, they were asked a series of questions. So we actually have 5 series if we think about the courses as the series unit, or we have as many series as questions we have. And just to make this a little more concrete, let me just get rid of a bunch of these columns. Normally I wouldn't delete columns, but let's just do it for this situation. And let's get rid of some of these. So we make it really simple. We have response ID, who the individual unit was, and then we ask them 3 things. What the course name is, how many students they had, and what level, is it graduate or undergraduate. So we have 3 separate series here for each individual. And some people just only had 3 classes, so they only entered a few. And some people had, 10 classes, so they entered a bunch. I guess they can only enter up to 5. So in this case, we have 3 series, and if we want to stack it, I'll go to stack here, drop them all in. So I just took them in as a clump. And then I'll say we have a multiple series stack with 3 series. And notice that we wouldn't say contiguous because the series itself are in separate places. So let's actually keep dialog open to make sure I did this correctly. And we should have These are all tell us about the course. Course 1, 2, 3, 4. Actually, these are contiguous, I think. Let's try it again. Like I said, I get this wrong all the time. Let's see. This is such long column names. Oh my God. Yeah, so they were contiguous. I apologize there. Yeah, so the orientation of it, let me go back to the survey itself. The series, again, identifies what we're asking about. So one series was the course name, the second series was students, the third series was the level of the course. So when we define them in here, they're next to each other, so those three series all have data in clumps. Yeah?
The contiguous option, the order is the one that is in the table or the one that you put in
the one that we, yeah, the actual one we put in here. So if we had done it separately, we could, take these like this. Let's actually do it. It's a lot easier if your table is oriented already, because then you're not defining it this way. But certainly if you did this, now this is three series that are not contiguous. Yeah, and that should, fingers crossed, produce the same table with these unruly long column names. There we go. Yep. So those are all the same question with the data. All right, so multiple series stack. Sometimes that's how your data is oriented, and being able to do it with a single operation and jump becomes really, really valuable. Okay, any questions on that one before we keep going? Great. So data aggregating. Now there are times when you have to apply a destructive method to make your analysis simple. And one that I like to talk about often is if you have data that you have multiple observations across, let's say something like years, and you want to do an analysis, but you don't want to treat those separate observations as independent. You just want to average over them to produce an analysis. So this is a simple example also from the sample data. These are US states, and we've measured things like SAT, so a standardized test, and we've measured them across years. So for any given state, let's just pick one of them, we have 8 observations because we have 8 years that these data have been collected over. So if you wanted to perform some kind of analysis, like how is this standardized test score for verbal, how is that related to, let's say, the salary of teachers? If we were to look at that in a scatter plot right now, the clumps here are really because of the states. They're states that are represented 8 times in the data set. And so if you were to do this as a regression and actually try to get a p-value for it, that is going to vastly overestimate your degrees of freedom. You are treating non-independent observations as independent, and that's not kosher statistically. What you really need is one observation per state. And so unless you want to treat this as a mixed model and do something more complicated, what you really need is a summarization or a tabulation of this. And so there are 2 platforms in JUMP that make this really, really easy. And it's table summary and analyze tabulate. They can do subtly different things, but for most cases, one of the 2 will be what you're going to use. Let's look at tabulate first, and then we'll look at summary and some of the good affordances there. So tabulate it's generally used for pivot tables, but you can also use it for summarization of variables. So just to give us a sense of where we're heading, what we're going to have is a situation where we have states across rows, and I'm going to do this more slowly. We'll have verbal scores as the mean, and we're also going to have salary for each state as a mean. And this is going to give us a table that we're going to be able to analyze, just like before. I'll do it in Graph Builder again, where we have verbal scores on the basis of salary with a regression, but this time we actually will only have 1 data point per state. So we won't have the situation where we're overestimating the degrees of freedom. So let me back up. The way tabulate works, which is really powerful, is that it's drag and drop like Graph Builder. And there are drop zones that identify the locations that you can put columns. And depending on where you drop things, it'll do different operations. And there's always this undo button, so it makes it easy to go back if you put something in the wrong place. For this type of restructuring, this type of tabulation, I always like to start with something that identifies the rows, because it gives you a table that's easier to operate on. And in this case, we want our units of analysis to be at the state level, 1 row per state. And so you'll see when I hover in different places, it highlights. And so the drop zone for rows, that'll identify for me the states. And so I'll just drop it here. And the first thing that jump will do is it'll identify how many rows you have counting within that grouping. And there's 8 rows per state here. And notice the tabulate's interactive too. So if I select here, it'll select in the table. Handy. But that's not good enough for us, right? We need now columns that represent the units or the variables of interest, but some operation over them such that we end up with 1 observation per state. And the variables we're going to use are SAT verbal, that standardized test, and salary. Now we can take them both at once and drag them into the middle. I don't know why it shows all the columns, but we're just dragging 2 of them. And if we do that, JUMP will pick a summary statistic. It says, okay, well, I have 8 observations for each state. I need to aggregate them in some way. I can't represent all 8 values. If it were to represent all 8 values, it would just be our data table again. Now, the most simple or default summary statistic is the sum. So it added up all the values in the table. Sometimes that's useful. In this case, it's not. We want to use the mean. There's 2 ways to change the summary statistic. I can drag the mean on top of that statistic. In JUMP's mind, almost always dragging on top of something else will say replace. Just so you're clear, you can actually drag to the left or to the right. So if I zoom in so you can see it. Oh, I can't zoom in while I'm doing that. Let me zoom in first. If I drag to the left, notice there's this tiny drop zone there. And in JUMP's mind, dragging to the left or to the right of something is the append or prepend operation. So I can have both summary statistics. I could actually drag a whole set of them. So you want to have all these summary statistics for each of those variables. You can do that. I'll undo. So you can do a lot with tabulate there. It makes it pretty straightforward. In our case, we just want the mean. So I drag mean on top of that. Now, just so you can tell, if you wanted a table that also retained another attribute of the variable, for instance, you wanted to keep, let's say, what region they're in. So region here is listed as a categorical. You can actually use that appending or prepending drop zone next to state. So remember, I could take region and drop it on top of state, and that would replace. So now we've summarized at the region level. Let me undo that. We have that prepending or appending drop zone. I'll drop it just to the right of state. And since there's only one region in which each state lives, it just gives me that variable now appended to this table, which is kind of nice. So we're almost there. We've made this tabulation. I can click done, and this is a fun little interactive tabulation. It's nice to have. You can print it out. But I think one of the more powerful things is you can make this into a proper data table. So under the red triangle, make into data table returns this nice table that now I can operate on. So this is where I can do that proper regression. Now again, this is destructive. If you were to get rid of the original table, you can't recover the individual years over which you've now averaged. You're not going to be able to get that back. But sometimes this is what you need for the analysis you're presenting. Okay, so that's using tabulate. If we were to use summary, we're going to do something similar, but it's not interactive in the same way. And so table summary, albeit very powerful, is going to be a dialogue-based method of doing this. Just so you're clear, in tabulate, there is also a dialogue-based version. So if you want to use tabulate, end up with an interactive table, but you like specifying the way that summary specifies, you can do that. By the way, Graph Builder, you may not have noticed, also has a dialog option. So there's multiple ways you can pop into these things if you need them. Okay, so summary. Summary will do the same things that tabulate can do, but it produces tables by default. Instead of producing a report that has a table drawn, what you get from summary is an actual JUMP data table directly. And so to produce the exact same thing we just did, we would take verbal and salary, and we're going to define a statistic that will operate on it when we group it or aggregate over it. And if we click on statistics, you can see we have the option. So I'll select mean here. So mean for salary and mean for SAT verbal. Now, I'm going to keep dialog open and just click create. So you can see without defining anything else, this just gives me the mean across the entire table, which sometimes is really easy. It's a fast way to get the average salary or the average verbal. It's almost always better to go through and do it from distribution, but if that's all you need, you can do that. But we wanted it across states, averaging over time. So we'll take state and define that as a group. Group defines rows. Subgroups define columns. So I want to show you what that looks like. I'll do group here, create table, just so you can see. we end up with the table that we wanted. But I'm not going to save that because I want you to just see how some of these other options work. Subgroup will define column operations. So if I take state and put it into subgroup, it's going to be a kind of a useless table for us. But now we have one row with the mean for, well, for every state, but also for salary and also for SAT. So they're all the way across this table. Not super valuable. You could do a multiple series stack at this point. This is a crazy thing to do. You wouldn't want to, but you could put them all in here, say multiple series. I think we actually have 51 because it's plus the District of Columbia. And we end up with, no, I didn't do that one right. I won't even do it. We have 2 series, rather, that are all across there. So you got to do stack a bunch of times. Just so you can see this works, because I just thought of this. Let's do multiple series, contiguous. There we go. So you could end up with, for each row, this is for every state for salary and every state for verbal. A crazy way to go about forming that table. But that's what subgroup does. Subgroup stretches across columns. Now, you may actually want to use both group and subgroup. So if we have states here, but we want for each region to have them separate, if region actually was crossed with state, you could have them across different columns. Or just really simply, maybe what you really want is something like this. So a table where you have regions across columns, just one row, because you want to copy that out. So subgroup is sometimes useful when you have lots of levels of that variable. It's not going to be that handy. Okay, so one final thing I'll say about summary, which I think is very valuable. If I bring back my mean here, put state back in as my group, and I'll keep it dialog open, that's fine. The table you produce with your summary is a linked table by default, which means when you select observations in this table, it links back to the original data table. Now you saw in tabulate, we could do that as well. That was the default report level table was linked. But one nice thing is in summary, that is properly linked. That also has some special affordances. So there are times when you want to aggregate over a variable, like we want to know the mean SAT verbal for Alabama, but we want that back in the original table. So we want to have a new variable in this table that says, what's the average for Alabama, for Alaska, for all those? We'll look at formulas in a minute, which make that easy, but there is a pretty simple thing you can do. By grabbing the column in a summary table, you can drag it back to the original data table, and JMP knows how to do the update operation. So it is actually updated and matched based on the linked column. So just say I have a sense of what I just did there. In the summary table, you kind of just click, wait for a second. Now you can drag that column, and you just drag it across. And so it'll do that average, but now have it across the different rows. So within Alabama here, which is these 8 rows here, the verbal average is the average of those values. Right, so it's just taken as a summarization. So summary is great. Table summary is a really valuable way to create these summary tables, have them be interactive, and it's also very fast. Just a point about this, if you're new to JMP, almost all the time when you do prep methods like this, a source script is saved to the table. And if even if you don't write JSL, JMP's written it for you to recreate this summary table. So if the original table were to change, so if I were to realize, oh gosh, that's actually 620 for that year, JMP will warn you that your final table has changed. If I just rerun the source script, it's remade that table using the new data. And so it's a real handy thing to have saved. Okay, so that is data aggregation. So check on time, we're at 9:17, okay, cool. Any questions on that before we move on? Okay, data merging. So there's a number of these tools under the tables menu. So joining, update, concatenating, query building. They all do slightly different things, but they all come down to the basic idea of you have data in different tables and you want to push them together. You want them in the same table. And that's very useful for JMP because JMP requires operations to be performed on data in the same table, with one exception, which is virtual joins, which we won't talk about really today much. But you can still have data stored in separate tables, but virtually connect them. And maybe I'll show that quickly with one of them. But just to give you a sense of what this looks like, I'll show you a final table here. So we have these world demographics. And for each region in the world, we have all these different variables. And so it's highly unlikely that this was the way the table was found online. Most of the time, these are formed by joining tables from different sources. So let's imagine, for the sake of this demo, that you have all these individual tables. That you have a table with population, you have a table with education statistics, you have a table with health statistics, right? So you have all these different tables. And what's nice is something links them all. That is, there's something in each row of the table that allows you to say the data from this table matches with the data in the other table. And that's territory. Almost always you have to have some unique identifier that allows you to make this relational system. And if you're familiar with relational databases, that's the fundamental idea. Something identifies the relations between the data in different tables. So JMP has ways to pull these data together. And this is a problem where what you're really doing is you have a table that identifies all the rows. Any one of these tables has all the rows, 239, but you have variables you're pulling together. And so this is an operation that really is best served with joining or updating. Concatenating, which I won't talk about until a little bit later, is just where you have the same columns, but you have rows from different sources, and you want to put them together tall-wise. Right now, we're kind of talking about expanding the width of the table. And so let's start with any one of these and look at how a platform like Join works. So here's a table with just life expectancy. So we have just 4 columns. And let's imagine we want to attach a table to it with the health statistics. We want to bring these health measures in. Now this problem is actually pretty simple because the rows are all in the same order, but for the sake of just this demonstration, let's imagine they're either all out of order or you only have some subset of the rows in the other. We're not going to simply do a copy-paste. Of course, here we probably could and be fine, but let's imagine it was more difficult. So tables join is a great place to start here. What join is going to let you do is, starting with the table selected, the final table you want to add the data to, or you can actually have it produce a new table, but we're going to add the data here. If you go to tables join, it says, first, what would you like to join this life expectancy data with? What table do you want to join this with? And let's pick health. That was the other table I had open most recently. And if I were to do nothing else right now, I'll just keep dialog open and hit create. JMP's going to yell at me and say, I need to match in some way. It's not just going to willy-nilly put the data together without you defining something about it. And so under matching columns, matching specifications, we need to identify to JMP something that's going to relate these two tables. Now, if it really is just row number, you can tell row number and JMP needs nothing else, and it'll make a new table where row by row, it just pushes the data together. And we end up with this table now with 8 columns. Right, that actually has the data from both tables. And in this case, that actually works. The data were in the same order, and so it's fine. But let's, again, imagine this was more difficult. So we're not going to use row number. Cartesian join, I venture to guess 1 out of every 100 JMP users has ever used. Cartesian join's a great little tool, and I'll show it in a second, but it's not what we're going to do here. And I won't even define what it is until I show you, because it's interesting. By matching column is what we're going to do, because we have columns in each of these tables, territory and territory, that identify the units. They are matching them. And the way you define the match for JMP, in each of the table I can select a column. Those are the columns in each of those tables. And I can just click match. And JMP defines the identity. Territory in the first table equals territory in the second table. Sometimes you have more than one column that identifies the unique units. Maybe you have first name and last name as separate columns, and the matching is based on both those two things matching. So you would specify another pair of columns and click match. In this case, that wouldn't be what I would do, but if you have a table that has 2 columns that identify the unique units, that's what you would do. There are operations, checkboxes here for how you want to handle circumstances that occur when you do a matching. If you have multiples, so let's say a certain region, Albania, is represented multiple times in the match table, the table you're joining with the original table, what do you want to do? Do you want to drop the multiples? Do you want to keep them? Right now, I don't have any checked, so it's going to keep any combination or any multiple that it finds, any duplicated rows. But I can toggle which ones I want to have. What about non-matches? So what if you have a really big first table that has all sorts of countries in the world? Your combining table only had a few. What if you only wanted to keep the complete records? So only wanted to keep the few table or few rows that was happened when you merge the tables and have the small second table added. So you can say include non-matches from the first table, and this little diagram helps you to see that. It keeps everything on the left, the first table, and adds just what it can from the right. You could do just the width table, keep what you can from the right and join what you can from the left, or do the full, keep everything whether or not it matches. So you have a table where some data is complete with the left-hand column, some data is complete with the right-hand column, and some data you actually have for both columns or both tables. That's the inner. So again, this is one where I would say keep the dialog open and play around with it. Most often, I leave these as this and I keep doing an inner join. I like to have the complete data. Sometimes it makes more sense to have the all the data, whether or not it's complete across the two tables. Okay, so those are options under the matching. Finally, there's some options under how you want to produce the table. Do you want to preserve the first table's order or the second table? Do you want to merge the data into the same table or produce a new table? So I can update the first table, what I'm going to do here. If there are columns in both tables that have the same name, what do you want to do with them? Do you want to match them or merge them? So territory in a case here. I have territory in both tables. I'm just going to merge them. By default, if you toggle that, you get something called a match flag. That will be an indicator of 1, 2, or 3. That jump will write to a column and say, what did I do with the data in this row? Did I find it in both tables? Did I find it in the first table? Or did I find it in the second table? That's nice to have. And then some things with how you work with the formulas. Do you suppress them before, or suppress them rather after they get copied? Or do you copy them in the first place? Let's just leave it all there. I'll hit create and just see what happens. I only have one territory column because I merged them. I have all the columns from each table, whether or not there were data in the first or second table. In fact, some of these were missing altogether, so it kept them. And I have now the columns from both tables included. All right, and the match flag here, notice it's writing a 3, 2, or 1. I guess in jump 14 we added a value label, which is a good idea because before it just said 1, 2, or 3. So now it says it was found in both tables. So what that means is world as a row occurred in both tables, and so here it is in this final table. Okay, before I do anything else, let me just show you a quick representation of what a Cartesian join is, because it's going to come in useful sometimes for your work. Let's say you have two tables, and what you want is a new table that has, it's called the Cartesian join. We're going to have the combination of all these levels. So I want a table that says in one column A, and in the second column 1, and then I want A and then 2 in another row, A, 3 in another row, and then B1, B2, B3, and then 3, or C1, C2, C3. That's called a Cartesian join. And so if I take one of these tables, I'll take the first one, I'll do join it with, let me back up here. There we go. Tables, join. I'm going to join Untitled 78 with, what is the Untitled 77? And under matching, I'll do Cartesian. I'm going to do nothing else and just see what it produces for me. So I have A1, A2, A3, B1, B2, B3, and C1, C2, C3. You may not think you'll ever need this, but it comes in handy sometimes when you're generating column names and you know you have something collected from a machine where you have these kind of combinations, combinatorials. And instead of writing a script, you can just make tables and have it produce you this list of columns. So we'll actually see that in one of our examples later. It's a surprisingly useful thing that occasionally is useful. Yeah. Okay, so let me back up. We just did one join. And if you were watching, we have a bunch of these tables that we're going to have to merge together. And that could be done with a bunch of joins iteratively, because join only does one table with one table at a time. But there's a much faster way, and that's Jump's Query Builder. So this was introduced in 13. That's right. Got better in 14. Query Builder uses Jump's implementation of SQLite in the back end, and it's really just a local version of a relational database. And so we can use tables as if they're in a database, as schemas, as tables in a database, and it'll find the relations between them. It does a pretty good job of guessing what the keys are what the rows and the columns are that match, such that it can produce a table and you can do things like you would do with a database. So I'm just going to specify arbitrarily some primary table, education, and I'm going to say that the rest of these are all secondary tables. They are tables that have data that I would like to add to education. My recommendation is whatever your primary table is, it just works best if that primary table is the tallest, that has all the rows that you could possibly match on. I'll add, table education is a duplicate, so let's add everything but education. Let's clear these all out. Okay, there we go. I don't know why now I can only cancel. Dogs did not, dogs I don't want to join. So it's found very noticeably for me that there wasn't a column that identified dogs to my world demographics, which is good because there's no way that those could join. I didn't have world regions in the dogs dataset, so I'll delete that out. Now I have the option to build a query. You can click run now and Jump will just make guesses about what you want. I'm going to click build query. What we end up with now is this section where we can now define among the available columns what the final data table we want to have looks like. I'm just going to say add all. I want all the columns that were in all those tables to now be in the columns in my final table. And if you look, I get a preview here. It's, that 200 and something rows long. It's actually 100 because it limits the preview. But now we have the rows, the columns from every table. And in fact, we also have that territory column duplicated multiple times because Jump agreeably, I said I wanted all the columns, so it's putting them in there. If I want, I can remove them from here, but I'm just going to leave it be. Just so you can see, Jump has actually also written the SQL for me. So if you want to convince somebody you know how to write SQL, you can have Jump write it for you with Query Builder. Don't do that. I'm just going to click Run Query so you can see. Now, in one step, Jump has produced this final table with all the columns from all those tables matched on those rows. So a real time saver. One final point I'll make, the scripts that Jump writes, there's some really powerful ones here. This joined table, or this query built table, gives you the option to modify the query, so I won't save that Query Builder window. If I click Modify Query, it brings back that Query Builder window so I can redefine how I did the joins and how I did the work. And really powerfully, if all those tables existed on your computer or on a remote drive somewhere and people were updating them, this update from database will call those tables again and redo that join. And so if there are new tables or new data that people have updated in there, it'll rebuild it for you. So Query Builder is really powerful. It's beyond the scope to talk about all the things it can do, but that's one where if you're constantly finding yourself joining, I would highly recommend learning more about. All right, lots of windows to close. Just so you know, if you ever are in this situation, you can do a close multiple. So if you have hundreds of windows you've opened, it's a nice thing to do this, and you could say only select the data tables or only select the scripts. So that's close multiple. I've already gone this far. All right. Any questions about those joins? Yeah.
Not about joins, really, in general. Any problem, actual industrial problem that you want to solve, there are many steps, okay? It's not just one of them. You
yeah.
One after another. And then again, you understand, okay, I have to go back. And again, all these steps, maybe stay there or I create another parallel session just to evaluate what if scenario analysis. So that's a little bit I find difficult with the Jump because I've been using some other software and that I really like there was really kind of some schema, okay, about the data preparation. Which
you have almost like a graphic showing
exactly.
stuff.
Yeah, you keep on doing and then you
I know.
okay,
Yeah.
blah blah blah. So
Yeah.
there is a visual way of tracing the things.
That's right.
And naturally, everything is scripted there behind the scene. So naturally, Jump can also do that. For example, whatever I'm saying probably can be customized using some script and understanding, but it's not easily possible.
Yeah.
Is that correct?
It's mostly correct. I would say you don't get the visual, and that's something we've really wanted too. Like I definitely echo your desire for that because it would be beautiful to see in that visual way. Here are the steps I did, and here's the import. And I can say there have been some attempts that I've seen people build add-ins that sometimes try to do that. My typical method is to build it via a script window. So every step I do within a process, and then just, within scripting, my favorite thing to do, so I'll call something data prep, and I'll say XPR. You wrap it in an expression handler, and what you end up with, if you toggle the right things in JSL, you can have these as little foldable code snippets. And so you can run them, and it's not as visual as what you're saying, but you end up with something that you can look at as a totality. And so you may have data prep as a section. You may have, this is like imports. Then you have another one and so you can run these all in a series. I actually have a webinar. It's called, JSL Scripting for Reproducibility. And I talk about a lot of this. I'm happy to send that link out to everyone if you want. But it talks about a lot of these data prep methods, but ways you can store your steps and procedures for reproducibility purposes, which is exactly that. It's
just not visual, but
it's not as visual. Yeah. But I echo the need. We would like that too. Yeah. Okay, I'm going to skip showing concatenate for a second. We'll come back to it, and update as well. We'll come back to it in a separate table. But I'm going to leave data merging temporarily for now, just so I can make sure to show you some additional things here. I think we go until it's 10 o'clock, right? Okay. This is Julian. Just continue to talk. Here we are, halfway through. Okay. Some of these go rather quickly, though. There are things I just want you to be aware of that really can improve what you can do with JUMP. So table views. So I'm going to pull open a table here. This is just restaurant tips. Now, in case you've never seen it, JUMP has lots of ways you can look at pieces of your data. And this ends up being very useful when you want to either simplify the problem in your head and you have too many columns, or you literally need JUMP to ignore completely certain rows or certain columns. So for example, what if the first 10 rows of this table is all you cared about? And what if the first 2 columns of this table are all you cared about? Under table subset, you can actually define how you want to pull out this little bit of the table. And so subset is very powerful. You can do lots of things we won't cover. But the simple operations are what you want to do with the rows you have selected and the columns you have selected. And I could tell JUMP, only give me a subset of table of the selected rows and the selected columns. I'm going to keep the dialog open here. And now I have this little subset of table that's actually linked, because you'll notice, I didn't link it here. Let me link it first. So the link option. And when I do that, this is the same table. If I change data in one, it'll change data in the original. And this ends up being really useful if you're typing data back into a table and you just want to focus your attention on one of these. So as far as the data prep method, it's kind of useful. Operations you perform in the linked table, go back to the original. We can have them not linked, so it'll create a subset. I only selected 2 at that point. It'll create a subset that doesn't actually affect the original table, so something maybe you want to modify or want to work with. You can also specify just the rows that you have selected but keep all the columns. Right? So subset is a really powerful way to pull out that little bit of your table. Now, one additional thing I'll mention about subset, the subset by ends up being very useful. Sometimes you have something in your table that you want to break out multiple tables from. So we have server here, so A, B, and C. I can tell JUMP to subset by server, keep all the rows and keep all the columns, and it'll produce 3 tables for me. So tables that included stuff from server A, B, and C. And I find this very valuable when you have to split apart a table and send out different versions to different people. And if you want to bring them back together, that was that table operation we didn't look at yet, concatenating. That's taking tall versions of tables that have the same columns and squishing them together. So I can say server A, B, and C. Those are separate tables with the same columns, and I want to pull them back together as a single table. So subsetting by and concatenating are the inverse operations, as long as you're using the same variable to combine them. All right, so subsets are really useful ones. Sometimes you don't want to go through the hassle of actually creating the subset like this. You can actually do something even simpler. This is one of my favorites. Let's say you have 10 rows selected, and your rows column or rows panel down here has some operations you may not have known about. In it, you can see, of course, how many you have excluded and selected. If you right-click on selected and go to data view, the data view are just those rows as a linked subset. And so at any point, if you just want to view certain rows, and this ends up being really valuable. Let's say you're in distribution and you're looking at a bunch of columns and you had identified a few that were weird. So you're like, oh, wow, those tables had high bills. You can go back to the table, right-click, and data view and look at just those tables you had selected, the really extreme ones. You can actually do that in distribution as well. So if you wanted to look at just the credit card yeses, if you double click, that is the data view of credit card yes. Be aware that the double clicking of the histogram, I keep going back to PowerPoint, the double clicking of the histogram honors what columns you have selected. So right now I have no columns selected. If you selected the first two columns and double click the yes, it'll only show you those two. Another trick you may not know, this section here, if you click there, that clears your column selection. If you shift click it, that selects all. Same thing with the rows. Clicking in this section here deselects, shift clicking selects all. So I can't tell you how many times people have asked me how they can deselect columns. It's just that little section there. But just be aware that the double clicking of a histogram bar anywhere will also produce the data view. Finally, the row editor. I think this is so handy. Let's say something about this row is really interesting. The person who tipped $14 or $15. So if we find that in the table, I'm going to Command Shift right bracket. That goes to that row. That's the operation under here. So row selection, go to row, or next selected. So those are really good things to know. If I double click the row label, it gives me the row editor. And the row editor shows you every variable's value for that row. And these are editable. So if I wanted to correct something and I found out, oh, it wasn't $15, it was actually $5, I can go and change that right here. And the row editor is great. You can toggle through rows and look at each row. It's a really nice way of, if you have a table with lots of data, you don't want to scroll across, you actually just want to edit that row particularly. Just double click. So that's the row editor. So subsetting, data views, and row editors, all really powerful ways. Not changing your data, just looking at it in a way that focuses your attention. So I find that very, very useful. Missing values, we'll get through this one kind of quickly because it's really easy to see. That world demographics data, there's lots of missingness. And you can scroll through the table and kind of get a handle on it, but with very large tables, you need to automate your way of looking at the missingness in a way that's useful. Two things I'll point out that I love under tables, missing data pattern, incredibly powerful. The way this works is you give it all the columns you want to interrogate for missingness. I'll actually just select everything. I'll keep all the defaults, and Jump will produce a table where what we've represented is all the different ways columns had missing data. And those are called patterns. Actually, let me just do this with only a few columns so you can see, then we'll look at it for the whole table. I'll do missing data pattern for just the first 3 columns. And so there are 4 ways really, that those first 3 columns had missing or non-missingness. The 0, 0, 0 refers to the columns. So this was a situation where 212 rows of the original table had no missing on any of the columns. So 0, 0, 0 means not missing, not missing, not missing. And I selected it here, and notice in the original table, those 221 are selected. Those are the complete data. And if maybe I wanted to analyze just those, I could just go to data view, and now I have a table with just complete data. Cool. Let me go back. There were one region here that had 1 missing in the second column, crude death rate. And you can see that because it's 0, 1, 0. That's the pattern of missingness. There were 6 where it was 0, 1, 1, missing on the second 2 columns, or second and third, I should say. And then we had 11 that had all missing on those 3 columns. And this is handy. If I select that and say, hey, exclude, this is a linked table. So excluding here excludes in the original table. Data are missing on everything, so maybe I actually want to delete those. They're not actually useful cases, but excluding is a much safer way of doing that. So that's missing data pattern. There are some scripts that are saved also that I find really cool. The tree map shows you proportionally what patterns were represented. So most of the data was complete, 0, 0, 0. And if I hover, you can see it even tells me that's the pattern, 0, 0, 0. 92% of the cases. Some were completely missing, 1, 1, 1. And then we had that mixture of missingness. And then finally, the cell plot, really cool. This is showing you what those patterns look like. So based on the missingness for each of them, the complete, 0, 0, 0, some with missing certain variables, and some missing all the variables. So that's missing data pattern, a really cool thing. And so it generalizes really well. If you do that with missing data pattern with all the columns, It's going to be a little more complicated to look at, either in the cell plot or the tree map, but it's showing you what the distribution of missingness is across all the columns. So now the patterns are very complicated, but you can see we have 88 that have complete data. If you want to know the fastest way to find how many rows you have with complete data, it's missing data pattern, because that'll find across all of them which ones are complete. And you have 11 here that are completely missing. So we can say those 11 rows are waste on us. We don't need them in a table, right? And some, you just can say, well, I really care about the ones that don't have missingness for certain variables. And so you can actually just do, and I'll show this later, select matching cells. You can right-click on any cell in JUMP and select matching. And so now I've selected all the data in this data set that has missing on that one, or any others I want. Very useful. The other option I'll point out is Explore Missing Values, which is a bit of a more elaborate platform. It's under Screening, Explore Missing Values. This will require numeric data. If I try to put categorical, it's going to yell at me, because this essentially is a stepping stone to imputational methods. We won't talk about them here, but I'll let it just use the numeric columns. Now, it does a lot of really nice things, but again, it's sort of a stepping stone to doing this imputation, putting in data where there aren't data originally. But there's some really cool things that this platform Apple gives you. So I love the missing value report, just tells you how many observations are missing for each of the different columns. The missing value clustering is so cool. This is a two-way clustering method, which says which rows tend to co-occur and how they miss data. And so the dendrogram, just like in hierarchical clustering, is telling you closeness based on the location in the tree. So if two, in this case, rows are close to each other, those are territories in the world, that means their missingness is very similar. And so if I grab a cluster that's similar, and let's do a data view, these territories are ones that have missingness that's pretty similar. And why that is the case, who knows, we can investigate it later, but that at least is kind of cool. And then the other way, since it's a two-way, if you imagine the rotation of this, this is which variables have missingness that is similar. And so if we look at some of these, it kind of makes sense. Health expenditure per capita tends to miss when health expenditure per capita rating is missing. One is a derivative of the other, so if we're missing the first, we're going to miss the second. And so it gives you a sense of which variables are related to each other based on the missingness in the data table. Yeah?
The color there, what does it?
Missing or not. Yeah. So for the rows, it just says red is the data weren't actually available. Yeah. So that's really cool. The other one that I really love is this missing value snapshot, which is a way, if you could look at a really high zoomed out level and black was missing in the table, that's what your table looks like. And that's sometimes really valuable. If your table is ordered in a particular way, maybe it's by machine type or something, you could spot really quickly, oh my gosh, like one of these machines was not spitting out data. Like you would spot it really quickly there. So that's the missing value snapshot. And then the rest of these are based on the imputational methods. Do you want to impute based on a presumed structure of the data? And that's beyond us here. But note that if you do favor imputational methods, they're all here and you can do some really powerful stuff.
Could we plug a software coming from R to impute data?
Sure. If you want to call like an R function, you mean? Yeah. So I'll just point to it here. If you look at the scripting index, there's an entire section just for how you work with the R commands. Actually, I'm already in functions here. And I'm happy to chat more about it later, but you can do what's called an R submit. So you just throw over the fence a function to R, and then you can pull back objects from R, which is really cool. And I like to do it with wrappers. So you can write a wrapper in JUMP that does that for you. Yeah. So that's missing values explore missing values. Very cool. Missing variables. Oh, yeah.
Can you show me how did you navigate?
Oh, how I got to it. Sorry about that. Yeah. So it's under Analyze, Screening. There's Explore Missing Values. And so once you're there, you just have to define what columns you want to use. And then you get into this one. Yeah. Yeah. Missing variables. So unlike missing values, this is where variables just don't exist in your table that you need to have. And I'll just use serial really quickly here. This is another sample data set. Lots of ways to make variables. I want to show a couple of them. Instant formulas are really cool in the table. Let's say you wanted to take, I don't know, sodium or let's do protein times fat. I don't know why you'd want to do that. Let's just say you want to do that. Select the columns, right-click, and you may not notice that there's this new formula column option, and you have lots of ways you can work with the columns you've selected. In this case, combine is an operation I want to do, and I want to take a product. And this will write to the table a column formula instantly. With two columns selected, you don't always have to operate on them as a joint operation. You can say, do something distributional with them. Do, I know, let's standardize. So that's taking the z-score. So that'll write two columns that are the standardized version of that. Now the way these are working, all three columns here, they're column formulas. It didn't just write the values. In fact, if I right-click and go to formula, you can see it's written the actual column function that operates on that column. And that's a really powerful thing because when you add or change data, it's going to update. So that's an instant formula. It's instant in the sense that it's in the data set. I can right-click, go to instant transform, let's say, and let's just do a log, So it just applies it to the data table instantly. Yeah.
Is this only for jump 14 or was it already available?
Jump 12. Yeah, it was added. So that's instant formulas. They're also existing actually in launch windows. So let's say you're going to distribution and you're like, oh, I didn't do the log of calories yet. And you don't want to go back to the table because you've come too far. So right-click on calories, you can do it right here as a temporary formula. So I can say right-click, transform, and do a log. And you know it's temporary because it's italicized. It's just existing here in the ether. And if I use it, it doesn't get added to the table, but it's actually utilized within the platform. And Jump does it in a really clever way. If we look at the script for this output, it's using something called the transform column function. And so all it's really done is made a transform column, a temporary column that it uses internally and doesn't do anything to the table. Just calls on the values in the table that way. Really cool. You can do it anywhere. So let's say you're in Graph Builder and you really wanted to look at fat on the basis of the log of sodium. Transform, log, and put that in the y. And that's a weird thing to do, but you can do it. So the other operations are also there. So distributional, combining, transforming, it's all there. So those are instant formulas and temporary formulas. They all work on the operation of a column formula. So for any of these that are column formulas, you see I have a big fat plus sign. I can click on that. That's the column formula for that column. If you make a new column, the way you add a formula is just right-click and go to formula. Jump has a huge number of functions that it can work with. Some incredibly powerful ones, character functions that allow you to do a lot of, we can do a whole talk just on the character functions for cleaning up data, but worth looking into. So like the word function, stripping off particular words of text. So if, I don't know if we have any, we do. So within the names, let's say we want the second word from each of the serial names. Right? That is a function now that'll return the second word of all the serials. So you can write your own custom functions that way. A lot of stuff in there. So column formulas are very powerful. Another thing that I find really valuable is using make indicator columns from Text Explorer. So let's say you're looking, and this is one of these off-label uses. If you're in Text Explorer, and this is good for pulling out the words within particular columns. So I'll pass the name over here. And let's say you want an indicator column for any time a column or a serial mentioned wheat. Now you could write a function that searches, you can go through a lot of work to write your custom JSL to strip through and look for the word wheat. Or you can just go to Text Explorer, right-click, and say, make an indicator column. There you go, save indicators. So with it selected, now I have the wheat indicator, where it's a 1 if that serial mentioned wheat, and it's a 0 if they didn't. Pretty useful. Sometimes you need to pull out something granular like that. Or if it contained corn, right-click, save indicator. And you can select a lot of these too, and save all the indicators at once. And so maybe you want to know, did they say wheat, corn, or honey? So instant formula, it's a 1 or a 0, right-click, do new formula, combine, and take the maximum. So that says if any of those was a 1, then now I have a 1 here. So now I have a column based on several characteristics of something I pulled from Text Explorer. Kind of useful. So maybe you want to only look at those, so you can right-click and do a data view. And now here are the serials that only mention wheat, corn, or honey. So a nice way to really quickly dig down to subsets of your data that are interesting. So Text Explorer, don't overlook it. Even if you're not exploring the text for the purpose of defining a structure numerically, it's a good way to just pull apart your data. All right. Finally, binning, and I'll mention an add-in here, but let's say you're looking at fat, and you, instead of wanting this numeric, you wanted this to be like low, medium, or high fat. So you want to make this into categorical data from numeric data. Don't always recommend that, but sometimes it's defensible, and that's what you want to do. So there is a function in the table. If you go to the columns menu with fat selected, it's under utilities, and you can do make binning formula. And a binning formula says, how do you want to cut up this numeric data, have a good day, to have categorical labels or outcomes? 5 minutes, unbelievable. I talked this much. I'll tell this one quickly. So offset just says, where do you want to start the first bin at, -1, and how wide do you want the bin to be? So I'll say the bin is 2 milligrams wide. And let's just use all the defaults. I'll hit make formula column. And now if I look at this, I have this bin version. -1 to 1, 1 to 3, 3 to 5, 5 to 7, 9 to 11. So I have a categorical bin version of that numeric data. And you'll notice that it's honored the original structure because it's just done bins of equal sizes. So if we look at that compared to fat, it kind of has the same shape. The smaller the bins, the more it's going to match the original shape. More often, I find that people want to bin based on quantiles. I want 25% of the data in the first section, 25% in the second, 25 in the third, 25 in the fourth. And that's where I would recommend this add-in that one of our colleagues, Brady has put together, the interactive binning add-in. I think Jeff originally defined it or made it, but it's a really nice add-in because what it lets you do is define these bins based on distributional characteristics. And so I'll launch this one pretty quickly. I have an add-in already here, interactive binning. And I can say, let's bin based on fat. It gives me the histogram. And one of the really nice options is I could say, set the cut points for the bins at percentiles. So at the 25 percentile, so I want 4 bins, each with 1/4 of the data. I guess it wants that to be numeric in full units. That's funny. So 25. And you'll see it's given me the little sections here. They're actually draggable, but I won't change it. And now I can go to the red triangle again and save a group column. So now I have bins here, 4 of them that are as equal as possible based on the cut points I've defined. So low to 0.5, 0.5 to 1, 1 to 2, and 2 to high. So that's the binning. So I'd recommend that. Again, it's called Interactive Binning Tool or Interactive Binning v2. Very powerful if you're constantly making categorical out of numeric data. Okay, wow, I've talked a lot. So I was going to leave a lot of time for questions because in my head I was going to get through this in like an hour. That didn't happen. Just to give you a quick sense, I want to answer questions, and I can stick around as long as anybody's interested until they kick us out. I will mention that there was other things I was going to talk about, and maybe I'll just record it and put it in the recording later. But talking about looking for extreme values in different ways, wrong values, so things like recoding. Please know there's an amazing recode tool in JMP. If you have a column that has things stored incorrectly, like people are entering the days of week all wonky, like they did here. There's this great tool under columns recode, and it's just so powerful. You can basically tell JMP to just like give a shot at recoding on its own. So group similar values. It'll figure out most of them. It may miss a few, and you can group them, and then you can recode to a new variable. Never do you have to do find and replace again unless you want to. So know that that's there, but learn more about it. And then some interactive table tools. We looked at a few of these, like select matching, but also remember that the data filters are your friend. In any data set, the data filter under the rows menu gives you a really powerful way to, let's say, look at subsets of your data. So if you want to filter based on calories, you can say only include and show in reports, calories from 50 to 100. Right? So to subset or to look at pieces of your data, it's so powerful. And that's available within every platform too. So if you're in Graph Builder and you're looking at calories based on protein, you can toggle a local filter on and say, let's look at that, filtering based on sodium. So show me this output looking at just low sodium cereals, and I can look at how that changes across the range of sodium. So filters are just incredibly powerful. And then there were some case studies, which it was very ambitious of me to think that we would ever do that, so I'm sorry. All right, I'm going to pause. and actually stop talking. In the last few minutes, are there questions I can answer for you? Or things that sparked your interest or hopefully you find value from? People learn things? This wasn't things you all knew, right? Okay.
For the data filters, let's
Yeah.
say you have files that are formatted about the same way, but you don't know exactly at the beginning how many variables you have, and you want to have a filter on the first variable and see the behavior of the selection on the other variables.
Yeah, that's a really good question. So the way you're going to do it, I'll use cereal here, and I'll do calories and protein are fine. So when you do a filter, what you're talking about are conditional filterings. So let's say you wanted to filter on fat, but you also wanted to filter on sodium. But you wanted your selection on fat to affect what got selected for sodium. Actually, let's do it with categorical because it's going to be a lot easier to see here. So I'll do consumer. Let's do consumer preferences. There we go. So with categorical, you'll see it more easily. So let's say we're looking at salary on the basis of somebody's job satisfaction, and we have a histogram, or we have box plots. So I'm going to do local data filter, and let's have age in years, and I'll do an and say let's look at I don't know, let's do years in current position. So under the red triangle, if I toggle conditional, what this will do is as I select here, it'll change the ability of what's selected here because the subset of those here, notice what happens. So you focus your attention right on this number, the 15. As I squeeze down the age in years, like if I'm looking at people up to age 27, there's nobody who's been at their current position for more than 7 years because, we don't have child labor. But if I say we're allowing people up to 74 years old, some people have been at their position at 20. So the selection on the second filter is actually changing what's available based on the first. I could do it the other direction. If I'm looking at people who are, older, there's nobody who had fewer than 8 years at their current position. So that's a hierarchical filtering system. It works the same way for categorical variables. So if I have, let's remove this and do it again. I don't know if we'll be able to see it as easily, but if I have a few of these and I'll do conditional, you can have a situation where, I guess we don't have any where it came up, but you could have a situation where some categories disappear because they just don't exist in the data. Actually, US demographics is probably a better one for this. But hopefully that gets at the question you're asking a little bit. Yeah. I'll do here this way. I'll do region, and then I'll add state. This is this is what I should have shown first. So I make a conditional. If I click on Midwest, only the Midwest states are showing. If I click on Northeast, only the Northeast states. So this gives you ability to drill down into it conditionally.
And if I didn't know the names and the number of variables that are related to each other,
yeah.
I need to do GSL.
Yeah, if you wanted to script this, one thing if you know that the ordinal position in the data table will always be the same, the first variable is the first one you want to filter by, the second variable is the second. There's a nice construct in JUMP where you don't have to call the column name. You can just say column 1, and that'll actually do the first column. And it's, or is it colon? I think I spell it out. Column 1, there we go. And it'll do that. But I would hesitate to suggest that as a general practice because order of columns is often something that people don't pay attention to. You can get a lot more creative with it and make a dialogue where people select, but yeah. Oh, absolutely. Yeah. So
that we'll talk about in the GSL.
Yeah. Oh, yeah. They'll talk about that. There's interactive ways for it, but so for instance, I'm giving you a talk later about health data. So here's a here's a dialogue that I built that actually calls an R script in the background. And so you can, make dialogues to do whatever you want. It's actually, JUMP is a very good environment for that kind of thing. Yeah, great questions. Other questions? And then we'll probably have to clear out because I think the next talk starts at, is it 10:30? Okay, well, we have a little bit of time then. I will continue to stick around as long as they will let me, or as long as you're interested. Other things that sparked your interest? Or challenges that you faced in your own data preparation? The question about stringing together multiple things is a really good one, actually. I'll just point to that webinar. So it's jump scripting reproducibility. Should get there. So I was doing this mostly for research scientists and academia, but it's called the Scientific Workflow in Jump, Creating Reproducible Analyses. And the whole idea of this is, how do you possibly script a workflow that you need to reproduce? And so for research scientists, it's really super critical because they're having to defend all the steps they did to say that they didn't, improperly hunt through the data for output. And so creating reproducible and documented analyses is critical there. But it applies to every industry. I always say, only work as hard as you have to. And if you are constantly every day doing the same series of steps to prepare data, there's no reason you shouldn't automate that. And so Jump makes it really simple. Almost every operation you perform in Jump will write a script, or every output in Jump that you can produce has a script. They're always under those red triangles. So there are ways you can, with a minimal amount of JSL, string together a series of operations to make it basically one click for yourself. Yeah. It's worth spending an hour or two to learn all those things to save yourself hours every day. Put it that way. Yeah. Any additional questions?